So I just have a couple problems at the very top, and they say review, and it says factor out the GCF of each expression. Does anybody remember what a GCF is? Greatest common factor. Okay, so you're looking at the biggest number and or letters that go into each of the terms that you've got in your expression. We're not solving anything. These are not equations. We're just going to factor a little bit. Okay, so can anybody raise your hand and tell me what would be the greatest common factor between 4x cubed and negative 12x squared? What would be the biggest thing that would go into both? What do you think? 4x squared. Okay, now 4x squared, they're both divisible by 4, and I have at least x squared in each of those terms. Now, how do I factor out that 4x squared? Like, what do you do to go about writing that in factored form? Does anybody remember? Like, what do I do with the 4x squared? I'm not saying that right because you guys are looking at me like I'm nuts. Okay. I kind of like to, I'll just do this first one with you guys, and then I'll let you try the other ones. Okay, so I like to think about it as literally undoing a distributive property. So we're going to pull 4x squared out of each of those terms. Okay, when I do that, what I'm really doing is I'm going to divide each of those terms by 4x squared. Kind of think of your properties of exponents there. So if I pull a 4x squared out in front, can anybody tell me, like, what would still be left in that first term? If I divide that by 4x squared, what would still be left, or would anything be left? What do you think? You're on the right track. We're not going to have a negative exponent here, so it's okay. If I take out a 4x squared, what would I have left in just this first term? Just x, right? Just x. I'm not trying to be mean or anything. Okay, look, like, so 4 divided by 4, that's 1, right? X cubed divided by x squared. So I've got x to the third, right? And I'm taking 2 of the x's out, so I'd still have 1 left. It should be, if I multiply this back together, it gives me what I originally had. What would I have left in the second term if I divide 12x squared by 4x squared? 3. Okay, so this would be your factored form, and you just go ahead and leave the parentheses there. We're not solving anything, we don't have an equation, we're just factoring the expression. Okay, what would my greatest common factor be for that second question between 6x squared and 2x? What do those two have in common? 2x. Okay, so if I take, we're going to like undo a distributive property to factor this. So if I take a 2x out in front, who can raise your hand? Tell me what would be left over.
3x plus 1.
Perfect. 3x plus 1. The one thing I really want to point out to you on that question, people always screw this up. When you take, and you have, I'm taking 2x, and that was the last term there, sometimes people just won't write anything, but you have to leave a 1 here. If I divide 2x by 2x, if you divide something by itself, it becomes 1. It doesn't just disappear and go away, so there should be 2 terms left there. Really good. Okay, now my last one, this is a little weird, and this is going to be kind of a little bit more similar to what you guys are going to see in some of the problems today. I have 4c plus the term a times b times c. What would the greatest common factor be between those two? C. Okay, that's all they have in common. What would be left if I take a c, and I'm going to divide both of these terms by c, pull that out in front. What would be left? 4 and then plus AB. And just for you guys' reference, typically if you have, and it's written this way in the problem, if you have more than one variable in the same term, they're just written in alphabetical order. So that's why you see ABC, and then when I wrote that, you just see AB. Anybody having a question about greatest common factor? We're going to use this today. It's just going to be in a couple minutes. Okay, what we're going to work on solving are literal equations today. So that's that little blank there. All this says is a literal equation is going to be an equation where multiple variables are going to be in the equation. So more than one letter in the same equation. What these typically ask you to do is solve for a different variable than what it might already be solved for. Some of them have numbers in them as well. Some of them don't. They're just straight up all variables. And so we're going to work on how do we solve these for a particular variable. Okay, the other thing I got to talk to you about before we do this, just real quick, restrictions on variables and these can exist. You don't have them in every problem. Okay, there's two situations that you have to worry about for a restriction, and that is that you can't divide by 0. And what you're going to look for there is if you have a variable in a denominator. Doesn't matter if it's in the top, but if you have a variable in the denominator of a fraction in your answer, there's a potential that you could introduce a value for that variable that would cause you to divide by 0. So we'll talk about that in a second. This is the more typical restriction that you got to worry about. So any of these questions, if we get a fraction as our answer, if there's a variable in that denominator, we'll have a restriction. The other situation, and this does not come up very often, is that you can't take a square root of a negative number. Doesn't exist. So it is okay to take the square root of 0, but you cannot take the square root of a negative number. So there's only one problem like this in the notes today, but just to show you how to take care of that, you just take whatever is under the square root, and you're just going to set it greater than or equal to 0. So if you end up, there's one problem like this today, if you end up with the square root, you literally just copy whatever the expression is under that square root, and you set it greater than or equal to 0. So that means it would be 0 or bigger. So that's just positive numbers and 0. It is okay to take the square root of 0. Really, the one we're going to see the most today is that first one I wrote down. So we're going to start going through some of these in our example here. All right, so I'm going to slide this up just a little bit. Some of these are actual formulas, and you'll see these in the homework too. The first one I have here is actually just the area of a triangle. Area equals 1/2 base times height, but it's solved for the area. And then the question's going to ask you to solve for a different variable. In this case, it's going to ask you to solve for the height. So we're just going to do a couple steps, and it'll just look weird because we won't be able to simplify it a ton like you can if you just have numbers in your equation. But we can still transform this to solve it so we have h by itself on one side. So anybody have any idea? I have area equals 1/2 base times height. What might you do first if you were going to try to get h alone? For sure. Okay, dispose of that lovely fraction. So 1/2, if you just multiply it by its reciprocal of 2, that'll get rid of it. Now, what it would look like, you would just have 2 times a, and then the other side, the 1/2 just cancels out, and then you're left with b times h. All right, ultimate goal, get h by itself. So I got to do one more thing. Anybody know what I need to do next? Oh. Divide by b. Okay, now this just looks weird because I don't actually know what number these variables represent, so you just kind of see all your steps in your answer. But when I do this, I get h is going to be equal to 2a over b. Okay, now I got to ask if I do have a restriction on this question. Okay, I don't want to divide by 0. So what is going to cause me to potentially divide by 0? Like, what do I need to write down for my restriction? Does anybody know? Yes. Okay, so the variable in the denominator is b, right? Literally, all you have to do, I can't divide by 0, so to write your restriction, you're just going to copy the denominator, right there is b, and then I'm going to put an equal sign with a slash through it. That just means it's not equal, and I say the b cannot be equal to 0, otherwise that wouldn't be defined. And that's my restriction. Does anybody have any questions? Okay, I'm going to try a different one. This isn't a formula for like area or anything like this. We're going to solve for x in this situation. So I have d equals, and then I have a fraction, 5x over a plus b. You can, raise your hand, tell me, maybe what would you do first if you were trying to get x alone? Could you multiply it by a, or do you do the reciprocal? You could. I might do one thing first, just so because the algebra might get messy if you're going to multiply by a, but I wouldn't recommend doing that first. What were you going to say? Try to undo any, and if you multiply by a, you just have to multiply everything by that. So if you have any addition or subtraction, I would get rid of that first. So I'm adding b. All I got to do is subtract it to the other side. I'm just trying to save you a little bit of step. So d minus b, because I'm trying to isolate that term that has the variable that I want. So if you have anything to the side of that term, try to move it first, adding or subtracting to this one's subtraction, and then get rid of any multiplication or division. Okay, what would I maybe do next here? I'm trying to get x by itself. Divide by it? And multiply by it. Okay, now completely up to you. I am not going to require you to like distributive property with that. I would just leave the a out in front if you want. Just d minus b here, and then 5x. Okay, so my whole ultimate goal is to get x alone, so I got to do one more thing, which would be what? Divide by 5. Okay, now you're all done. Once you do that, we're just leaving the steps. They kind of just appear because I can't actually divide by 5. I don't know what those variables represent. So my answer would be x equals a times d minus b, whole thing over 5. Okay, does this problem have a restriction of any kind? No, I have a 5 in the denominator, so there's no potential for me to plug in something for a variable that would cause that to be 0. So you don't have to write this, but this one just has no restriction. I don't have a variable or any kind of expression with a variable in the denominator, so that would just be my answer. Anybody having a question? Okay, let me scooch this up. So my next one, I just have c, and that's equal to a plus b over 4. Right, and I want to solve for b. What do you think we should do first on this one? What do you think? Let's multiply by 4. Okay, so I've got the whole thing is a fraction there, so the easiest thing to do is get rid of that fraction. So on the other side, you're just going to have 4 times c. That gets rid of the fraction, so we just have a plus b on the other side. I'm trying to get b alone, so I got to do one more thing. Anybody know what that is? Subtract to a. Okay, sorry, I should have asked for people to raise hands. Okay, it's just weird because I can't actually subtract it. I can't, these are not like terms, so everything just stays separated here. But now I have b by itself. Does this question have a restriction? You don't have a denominator at all, so there's no potential to divide by 0. So this is just your answer, no restriction of any kind on this one. Okay. Oh, sorry, this is kind of faded here. It says solve for x in this next one. So I have 3ax, all one term, and everything's multiplied together, plus b equals c. What would you maybe do first? Just raise your hand and tell me, what do you think, if I'm trying to get x alone, what would you do first? Move the b. Get rid of, if it's in a different term, get rid of any addition or subtraction first. Okay, so I have 3ax and just c minus b. We just can't actually subtract that because I don't know what c or b are equal to. What do you do to get the x? You can actually just do one more step. Yes, you could do it all in one step. You're multiplying everything here, so you're going to divide to get rid of it. The whole thing just over 3a. So x is by itself, c minus b over 3a. Okay, now, this one does have a restriction, because I got a variable in the denominator. Does anybody know what the restriction would be for this one? Perfect. The 3 doesn't matter. It's the a. If you plugged in 0 for a, that would cause that denominator to be 0. So just say 3a, or sorry, just a can't be equal to 0. Does anybody have any questions? Okay, each one of these is just a little different. All right, now these are going to be, a couple of these on the back are going to kind of use what I was given to you guys at the top of the notes that was a little bit of review with the greatest common factor. Okay, now these could look different but have the same algebraic equivalence. It's going to depend on how you do a couple of these problems. I might have two answers on the answer key. Okay, now, this is going to say we're going to solve this equation for r. If you look at this problem, though, what I immediately notice is that I actually have r in two different terms. So a goal to have an r by itself is going to be a little weird for this question. What you want to do is you want to make sure all the terms with the variable you want are on the same side of the equation. Anything else is on the other side of the equation. So there's different ways you could do this. What I'm going to do just real quick, I'm going to subtract r from both sides. And just in the same step here, just to save myself some space, there's a plain A on that left side. I'm going to move that to the other side just right in the same step. My goal is to get all the terms that have r in them to one side and anything else on the other side. So I would have a times r just minus r, and then the other side would be b minus a. So I'm just trying to move all the terms that have r, so I'm just kind of rearranging stuff. Okay, now, just ignore this for a second. Ultimately, I want r by itself. What is the greatest common factor between a times r and that negative r? R, right? There's an r in both. So we're going to do what we did on the front. I'm going to take an r, so I'm going to divide both of these by r. Just a plain r comes out in front. Sometimes people get confused about this and they'll put a 2 with that. Don't do that. You're just going to take an r out of each term, just a single one, greatest common factor. What would be left over if I do that in the parentheses? Perfect, a minus 1, right? R divided by r is 1, so this would be a minus 1. And then on this other side, I know I had my pen covering up, but this is b minus a. Now, once you have this, there's literally just one more step to get r by itself. Does anybody know what it would be? What do you think?
Divide by a minus 1.
Yeah, you could, the parentheses, you have r times this. So you can just divide by that set of parentheses. Now, do not, as you go over, go, oh, there's an a in the top and an a in the bottom, and cross that out. No, 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 no. Okay, if there's adding or subtracting, don't mess around with that. Nothing else cancels out, okay? If it's all multiplied, we have a different story, but that's not what's going on here. There's subtraction in the top of that fraction. There's subtraction in the bottom of that fraction. Nothing cancels out here. This would be my answer. You can't factor anything any further out of the top or bottom of that. Nothing else simplifies. Just leave that alone. Now, I do have a variable in the denominator here. Does anybody know what the restriction would be for this question?
Is there non-restrictions? Is there still be
There is going to be a restriction here because I do have a variable on the bottom. It does not cancel. Say that one more time. Not necessarily greater than 2. I just don't want the bottom to be 0. It's not going to be 0 on this one. A can't equal 1. You just don't want the denominator to be 0. Okay, now if it's complicated, like this is a little complicated, you can always do this. Just take whatever is in the denominator and say that cannot be equal to 0. And if you could maybe manipulate a little bit to solve that, which is what Natalie did here, we're just going to add 1, kind of this inequality, but a could not be equal to 1, because then I'd have 1 minus 1, that would give me the 0. But if you're not real sure about it, just take whatever's in the denominator, copy it, say it's not equal to 0, and then see if you could maybe solve it a little bit so you have a variable on one side. That's a really hard problem. Okay, let me try this one. We're just going to do one thing real quick. I'm going to solve this for x. I have two terms, kind of like this last question, that have x, but I also have these numbers here. So I'm just going to move this 22 to the other side because that term doesn't have an x. You're going to try and get all the terms that have that same variable on one side of the equation. So all I'm doing here is adding 22. Okay. Now, what do these two terms, the ax and bx, what do these two terms have in common? x. So I'm going to pull an x out in front. What would we have left over? A plus b. Just a plus b. I'm taking an x out of each of those terms, just like undoing a distributive property. This is equal to 37. Okay, I'm going to divide by a plus b. Nothing is gonna simplify or anything like this. It just looks kind of complicated. It's going to be 37 over a plus b. Now, this one, I do have variables in the denominator. This is very tricky, okay? So I'm going to write this out. Whatever's in your denominator, you cannot divide by 0. So I'm going to say a plus b cannot be equal to 0. If you could maybe solve that just a little bit, which I'm going to do with just one step, I'm just going to subtract b from either side of that. So the restriction would be a can't be equal to the opposite of b. Because if we would plug numbers in there, if we would add that up, that would cause that to become 0. Does anybody have a question? Okay, I'm definitely going to do number 7 with you guys here real quick because this has a different kind of restriction. You're going to see a squared. And sorry, I'm just trying to go kind of fast because I didn't realize we were low on time. Okay, I'm going to move any addition or subtraction to the terms that don't involve the variable I want first. I'm going to try and get t alone here, so I'm going to move that 7. So I've got t squared over a is equal to b minus 7. All right, ultimately I want t by itself, so I got to get rid of the a in the denominator. So I'm just going to multiply both sides by a to do that. Now, I'm going to have t squared, and you don't need to actually multiply this. If you want to just leave it in factored form, I'm going to write a times b minus 7. Just leave it like that. What I want to know here is, do you guys know how to get rid of the squared? Square root, right? Okay. Now, if you introduce, like I'm introducing the square root, right, to cancel that squared out, if you introduce the square root into the problem as part of you solving the equation here, does anybody know what symbol I have to put if I introduce the square root? This is very neat to me. If you put a square root in a problem? Okay. Don't write this down. Okay. If I give you x squared is equal to 25, how many answers does that question have? Heart attack. Okay, if you introduce a square root into a problem, you have to put a plus and minus symbol because there's two things. If I plug in 5, like 5 times 5 is 25, but if I do negative 5 times negative 5, those negative cancel out and you also get positive 25. So anytime you have a squared, there's 2 answers. So if you introduce the square root, which we introduced the square root, you just got to put that little symbol in there. Okay, we clearly need to go over that. All right. Minor heart attack. Okay, so just need a little plus and minus symbol in front of that. Okay, now the restriction here is super easy. You just got to remember you can't take the square root of a negative number. So you're going to copy down whatever is under that lovely square root, not including the square root. Okay, just whatever's under the square root. This is going to be my restriction here. So this a times b minus 7. And I'm just going to say that has to be positive. So to write that algebraically, I'm going to say that expression has to be greater than or equal to 0. It is okay to take the square root of 0. That's defined. It's not okay to square root a negative number. Okay. I'm going to try to do one more here. Let me do number 9, and then I'll just leave the other 2 and don't worry about going back because we're going to run low on time. Okay, let me do number 9 though, because this one's super tricky. All right, now, I'm trying to solve for W. This is the last one we'll do. You do have a W in 2 different terms. Okay, you got a couple options here, but if you've got parentheses, you might have to distribute. In this case, what I might do is I might just go ahead and multiply both sides by the reciprocal, which would be a half. That would cancel out the 2. So I'd have 1/2 A. Now, that'll allow me to drop the parentheses there. And then ultimately what you want to do You want any of the terms that have the letter you're looking for, which is W here, on one side, everything else on the other. Okay, so for this one, I'm going to move that L times H, because that doesn't have a W in it, to the other side. All right, so I have 1/2 A minus L times H. We get LW plus WH. And then what I'm going to do there, very similar to some of the questions we had at the top of the page. Both of these have a greatest common factor of W. So you're going to pull that out in front. So this would be W. And then L plus H would be left in parentheses. And I know this looks super complicated, but we're going to divide both sides by L plus H. All right, so I would have 1/2 times A minus LH, the whole thing, over L plus H. And you can just, I'm not on the screen even, you can just leave it right like that as your answer. And then just remember for your restrictions, you cannot have a denominator equal to 0. So L plus H could not be equal to 0. I would take that, if you put that on a test or quiz, I would take it right like that. Or if you want to just take it that little extra step, L cannot be equal to the opposite of H. That would make that, oh, that is shaking all over the place, sorry. That would make that denominator equal to 0. Okay, sorry. Is anybody having a question? I talked for way too long today. I'm sorry, guys. So the homework this evening,